Bismillahirrahmanirrahim. Welcome to Diode and Application Season 2, brought to you by, of course, Easy Learn. And first of all, let's talk about the topics we are going to discuss today. Today we are going to discuss a new topic, that is a laser diode, and very precisely we will cover laser diode. As you can see that this is the image of the laser diode. This is a beam that is coming from the middle of this and we will discuss the process that is involved in the laser diode, how this beam is ejected from this diode. This is very small in practical cases, and this is the zoomed image, and you can see that this is from the outside we cannot see that what's inside. And working principle, we will focus on the working principle of this laser diode, and ultimately at the end we will also discuss some applications where it is used and where you found this diode. Okay, the term laser stands for, L stands for light, and A is for amplification and stimulated emission of the radiation, so it becomes laser. You can see that I highlighted this portion, and basically this is the light amplification by stimulated emission of the radiation, amplification of the light by the stimulated emission of the radiation. And this is the process of the laser diode. Laser diode is first of all very important parameter, that is monochromatic. Monochromatic means that which has a single color, means to say that only single color, that does not contains any, we cannot split it into further colors. For example, if we talk about the incandescent bulb light, or you can say that sunlight, we can split the color into different colors because the light of the sun is made up of the combination of the different colors. So we can split easily with the help of prism, and we can split also it's splitted naturally when after the rain, after the rainfall, when the sunlight falls, definitely you saw a rainbow in which different colors are visible, that colors are basically involved in the sunlight. Laser diode is also called coherent light. This is the same thing, that is monochromatic. We can also say that it's coherent light. Coherent means a single frequency, constant frequency. For example, we say that if 650 frequency, then coherent means it's fixed 650 frequency, we cannot change. If I said that 600 nanometer frequency, it's fixed 600 nanometer frequency, I cannot change it 1 nanometer above or below, it's fixed. So if I cannot change wavelength, so because wavelength is involved in the colors, as you can we had already explained in the previous episodes. So if we are not going to change the wavelength, of course color does not change, because color is also depend on the wavelengths. So this is the same point, but it is written in a different angle. So as compared to incoherent light, which consists of course band of the wavelength, that is again example of the sunlight, the laser diode normally emits coherent light, laser diode, and LED emits incoherent light. So symbol is the same as of the light emitting diode, LED symbol, and this is the working diagram and inside diagram of the first titles picture you had seen. This is the anode sheet, and this is the cathode. This diode is also operated in the normal region of forward bias, its normal operation region, which means its anode is connected with the positive and cathode will be connected in negative. So if anode is connected with positive, it means P side, we are powering P side with the positive and N side with the negative, and here N side is rich with the electrons, while P has excess of the holes. When negative pushes the holes, because like charges always repels, so the electrons tries to cross this depletion region. Here this is depletion region, this is the width of this depletion region, and when they are tries to cross there, this depletion region is gallium arsenide, made up of a gallium arsenide mostly. This is very important. We use gallium arsenide because the doping of gallium arsenide is very important here. It doesn't allows to cross here in anywhere and just provide us a coherent light, and so we use because of these type of properties we used here. And very important thing another here, that is the highly reflective end. This is the highly reflective end. The one end is always highly reflective, and to produce a monochromatic light or single beam like laser, this is very important. Okay, second is the opposite end is always partially reflective end, and this is the p-n junction. Okay, next slide. In this slide, a p-n junction is formed by two layers of dope. I had already explained. I wrote these points in details because I will provide at the end of this video in description this lecture slides that I made, and I will provide you. That's why I added in details, so that maybe you can you want to read by yourself after this lecture. So I added all the details in these points so that you can read by yourself also when you are by yourself. So there is all highly reflective, and I had already, this is the resonant cavity here, and important means that this is a cavity. This is enclosed sandwiched between p and n region. So this creates a resonance cavity. I will explain this in upcoming slide because there is a better picture there. But right now this is a mirror surface. Another diagram here, color diagram. This is a mirror polished surface, and this is the polished but partially polished reflecting surface. So this is the gallium arsenide and p type region and n type region. So this is the can type laser diagram, and laser beam can be emitted from the here. This is the same diagram as we see in the first slide, and this is the open diagram, animated diagram, sorry, not animated but conceptual diagram. And this is the cap, and this is the laser chip here. This is very important. Laser chip emits the beam of the laser light that we use, and this is the other circuit parameters. Another diagram, but here this is the heat sink involved. Also heat sink, this is a heat sink to sink the heat and to transfer it here heat, and window where the light emits, and monitor photodiode. This is the monitor photodiode and other parameters. A laser diode is a forward bias by the external bias source as electrons. We are already explained this. And coming toward this picture, that's I want to explain. These are the electrons that are pushed from the negative. So when negative is connected to the n region, the electrons tries to go and cross this region, while the holes are pushed from the positive side, which tries to cross this depletion region. But this is of gallium arsenide. That's very important. So when the electrons and hole pairs are combined in this region that is of gallium arsenide, the energy is lost. As for example, this is the band gap of the electrons. For example, electrons at higher energy band gap, and this is the band gap of, for example, holes. So when they try to go this region, and energy is lost here, the recombination energy is lost in the form of photons. But remember, due to the gallium arsenide is a very special case, a monochromatic light will be emitted. Okay, when monochromatic photons, let's say these arrowheads means that photons. So when these direction of photons is like this, but due to resonant cavity, many photons are released in a huge number, and tries to go here and there is no way to emit. But there, when these electrons are moving randomly and are striking on the walls, when there is a mirror, when when an electron falls at exact 90 degree to the reflective end of the mirror, then definitely it will also move back after as a reaction of the image, as a reaction of the reflecting mirror, same 90 degree. And when it comes here, it will go outside and make a beam of the light as the purpose of the laser, and we can see the beam of the light. So here another important parameter is this: when the beam of the light that is reflected from the mirror is coming, and in this way more electrons, for example in this way these electrons of other photons are moving in another direction, are also line up, because this photon is moving very fastly and have enough energy. So this process is also called like an avalanche effect in the resonance cavity. Okay, further discussion: each photons, these are the characteristics you can read by yourself, and below which yeah, this is an important point right now. The laser diode have a threshold level of the current above which the laser action occurs, okay, above which. So that's why in the previous slide I will also explain another point here. These electrons required a higher current, and the threshold value, below the threshold value, this process will not occur, that this beam will not occur. This beam, if will not occur, it will behave like a normal LED diode, means to say not a monochromatic light, have a more bands, have a bundle of couple of bands width involved, so it may be changed towards the chromatic light, change from the behavior change to, and it looks like a normal LEDs as shown in the figures as well, below which the diode behaves essentially as an LED emitting incoherent light. Okay, these are the applications. Laser diode and photodiodes combined package is your photodiodes are already discussed. Photodiodes are used for detection purpose, counting purpose as well, are used in the pickup system of the compact disc CD players. Okay, compact disc CD players, this is a CD player. How these CD players we can use this diode? For example, if this diode is used, for example, this is a beam of the light that is emitted from the laser diode. Remember, laser diode always emit the beam of the light at 90 degree, or you can say straight, but we can move and bend it to the desired angle with the help of the glass, or with the help of the lens, different that are used to bend this light. Here we are use this to read. This is the actually diagram that I had shown in the very first slide of my lecture, and this is used in the here in CD players. And how this reads, actually basically this is the conceptual diagram. On the surface of the CD cross-sectional area, for example, this is the cross-sectional area of CD. Remember, it's very very small and we cannot see it from the naked eye. Okay, CD room surface, this is the surface of the CD room, and let's say this is a 0 and this is the 1 of binary. Binary data is stored on the CD, digital data, and of course binary has just two levels, zeros and ones. In the form of zeros and ones data is stored, and let's say we say that is the bit, and this is a bit 0 level, and this is a flat. So in the form of bits and flats data is stored. When this bit and flat occurs, laser beam has a different and photodiode detect that there is a change. So we can also read this data as, this is a theory of I had skipped this, you can read by yourself. I explained this how this works, and this is this is the diagram, actually practical or real diagram. You can see that this in circle, this is the photo diode and laser diode combination, and laser diode is used to read the data and to convert back here. This is another diagram, another same is the case here. The photodiode is used and to detect, and for laser diode is also used for reading the data and converting back into the if for example it's an audio then track, then the laser light which is altered by the pits and flats along the recorded track is reflected back from the track through a lens and optical system to the infrared photodiodes. This is what I was trying to explain with the from the diagrams. Okay, the signal from the photodiode is then used to reproduce the digitally recorded sound. Laser diodes are used in the laser printers, fiber optic system, and laser projectors, as well as other applications. Many cannot explain all the applications here, so few applications, these are just few. So this is a laser, and the starting point is laser. When laser is we can change the laser to our optical with the help of optical lens processing units, and by passing to and at the end ultimately a wide image is obtained, a zoom image which is a projection of shows the screen. So here another application, that is the laser diode, is again create a starting beam, and here this is a 6-sided mirror that can be rotated also, and when it falls here at one angle, for example at this angle, it will goes towards fall on the tuner, hopper and drum, and here this is the basically paper that is moving from this side and rotate from this process. It's emitting from this angle, so it's used in the printing, that's called the laser printers. So this is very important. Okay, in the upcoming lecture we will try to focus the Schottky diode, but see you next time in the upcoming episode, because this will be explained in the next episode. Time is up, so take care. Allah Hafiz.